Hello Management Science students. Today we are going to solve linear programming problems using the Simplex method. We are done with the graphical method before the lockdown, so today we move on to the Simplex method. To verify that the Simplex method will give us the same answer as that of the graphical method, we will be solving these problems first using the graphical, and then I will be guiding you step by step as we solve using the Simplex method. By the way, we have here two problems, one maximization problem and one minimization problem. Okay, so we will be solving the maximization problem first, followed by the minimization problem. By the way, these problems are already solved in class using the graphical method, but I will be repeating the process so that you will be refreshed. So we begin. The Alpha Furniture Company manufactures dining room tables and chairs. Each table requires 50 board feet and 3 hours of labor. Each chair takes 20 board feet and 4 hours of labor. The manufacturer has 3,300 board feet of lumber available and staff able to provide a total of 380 hours of labor. Finally, the manufacturer has determined that there is a net profit of 100 pesos for each chair sold and 200 pesos for every table sold. For simplicity, we assume that needed materials such as nails and varnish are available in sufficient quantities. How many tables and chairs should the company manufacture in order to maximize its profits, assuming that each item manufactured is sold? Okay. Recall that in our classes, I told you that we need to capture this situation into a mathematical model. The model that we will be creating must be able to accurately represent the situation or the problem that we are trying to solve. Remember also that our linear programming model must contain the objective function and the constraint functions. Our objective here is to maximize, okay, as stated in the problem. And therefore, our objective function must be able to reflect that. But first, let us represent some variables. Okay? So, in this problem, we are going to let T be the number of tables to be produced and sold. Okay? It is said in this problem that we are to assume that each item manufactured is sold. Okay? So, we will let C, okay, be the number of chairs, okay, to be produced and sold. Okay, to be produced and sold. Okay, so we are using the letters T and C for simplicity. Although you can use any other variable you would want. Okay, the more common variables to be used are X and Y. Well, there's no problem, but I think this is easier, so that throughout the solving process, whenever I see T, that would mean table. Whenever I see C, that would mean chairs. Okay, so it's simple that way. And finally, let us represent P. Okay, we let P be the amount of profit. Okay, amount of profit to be generated. Now that we have represented the variables, we now proceed to the objective function. Okay, so we are to maximize, as stated in the problem, we are to maximize the profits. Okay, so our objective function will look like this. Maximize the profit, which is equal to 200 T plus 100 C. Why does the maximization, or why does the objective function look that way? Okay, it's because we are trying to capture this situation here. Okay, that there is a net profit, okay, of 100 for each chair sold and 200 for every table sold. Okay, so at this point, we don't know yet how much or how many tables we are going to produce, nor do we know how many chairs we're going to produce. So that is why these are represented here as unknowns. But what we know is that for every table that we are going to sell, assume that T is equal to 1, okay, then we are going to get a profit of 200. Assume that C is 1, meaning we are going to produce and sell 1 chair. Then we would get a profit of 100. So if we produce 1 table and 1 chair each, our profit would be 300. But again, the problem is we don't know yet how many tables or how many chairs we are going to produce. But this function here could still capture the situation because whatever number of tables we are going to produce, we just multiply it by 200, we get the profit. And in addition, the number of chairs times 100 would be the profit. Okay? So this function best represents this situation here. Okay? Now we now proceed to the constraints. Okay? Basing on the problem, we have constraints as to materials and labor. What materials are needed? We need lumber, okay, 500 board feet, 50 board feet for every table and 20 board feet for every chair. Okay, there are 3,300 board feet of lumber available. Okay, we also need nails and varnish, but we are to assume that nails and varnish are available in sufficient quantities. No matter how many tables or how many chairs we're going to produce, there will be enough nails and varnish. So this is disregarded. This will be insignificant in our solving, in solving the problem. Okay? So we only have 2 constraints, the materials and the labor. Okay? So for simplicity, okay, or to facilitate the formulation of our constraint functions, we draw a table. Okay, because this way we might be able to, facilitate the construction of our constraint functions. It will be easier this way. So, okay, tables, chairs, okay, of course we need wood or lumber, okay, or timber, whatever, okay, and we also need labor, okay, which are represented in hours. Okay, so to create 1 table, okay, we need how much wood? 50 board feet. Okay, so 50 board feet. Okay, how many chairs or how much wood, okay, does it take to produce 1 chair? According to this problem, 20 board feet. Okay, so 20 board feet. Okay, how about for labor? How long does it take for a table to complete? Okay, according to this problem, it needs 3 hours of labor. Okay, so 3 hours. And for chairs, 4 hours. Okay, maybe because the chairs have more intricate designs than the tables, that's why it would need more hours. I don't know, we don't know. Okay, what we do know is that it takes 3 hours to produce 1 table and 4 hours to produce 1 chair. Okay, so this would now be our constraints. Okay, this is 1 constraint, this is another constraint. So this is now constraint number 1 and constraint number 2. How are we going to convert that into a mathematical function? Okay, simple. We already have our representations here. Okay, so for the first constraint, okay, we would be representing it, okay, by writing this formula here. Okay, so 50 T plus 20 C, okay, is less than or equal to 3,300. Okay. Okay. According to this problem, there are only 3,300 board feet of lumber available. Okay. So for every table, that is going to be produced, we need 50 board feet. Such that if we are going to produce 2 tables, we will be needing 100 because 50 times 2 is 100. If we are going to produce 3 tables, then that would be 150 board feet. But we don't know yet, okay, how many tables we're going to produce. Okay, we don't know yet. That is why it's represented as 50 times t. Whatever the number of tables we are going to produce, multiply it by 50, then that would be the number of, or the amount of wood needed. Okay, added to 20 times c. If you're going to produce 2 chairs, then that would be 40 board feet. Assuming we are going to produce 2 of each, 2 tables and 2 chairs, then how many board feet do we need? That would be 100 plus 40. That's a total of 140 board feet. But again, we don't know yet how many tables or chairs we're going to produce. That's why it is represented by these variables. Okay? But take note that the total amount of board feet to be used, or the total amount of wood to be used, must not exceed 3,300 board feet. Why? Because there are only 3,300 board feet of lumber available. Okay? It can be equal to 3,300, meaning we have used all of the lumber available, but it cannot exceed. Okay? It can be less, of course, but it cannot be more. It can be equal. We can use up all of these lumber available. Okay? Second constraint would be 3t plus 4c is less than or equal to 380. For every table, we will be using up 3 labor hours. For every chair produced, we will be using up 4 labor hours. But the total available hours is 380 only. So, we must not exceed 380 labor hours. Okay? So, we're done with the objective function. We have 2 constraints here. And, of course, needless to say, we will have a third constraint, which we call now the non-negativity constraint. Okay? This is just to ensure that the values we are going to get after solving this problem would be not negative, because that would be so absurd. We cannot say, in order to maximize the profit, we are going to produce -2 tables or -3 chairs. No, that's not possible. Okay, so we must ensure, by placing the non-negativity constraint, we are ensuring that the values we are going to derive here, okay, would always be positive. But it can be equal to 0. It should be 0 or positive, but never negative. Okay, so how would our non-negativity constraints look like? T must be greater than or equal to 0, and C must be greater than or equal to 0. T can be 0, meaning we are not going to produce any table at all. We will only be producing chairs. On the other hand, C can also be equal to 0, meaning we are not going to produce chairs. We are going to produce only tables. That's possible. Okay? But it cannot be less than 0. It cannot be negative. Either one of these could be 0, okay? But they cannot be, any one of these variables cannot be negative. Okay? It should be 0 or positive only. Okay, so we now have these constraints. Okay? Remember that these constraints represent a line in the Cartesian plane. Okay? So in order for us to be able to plot these lines, by the way, these negativity constraints automatically become our axis. Okay? Okay? So in order for us to be able to graph, okay, we will be needing the Cartesian plane. Okay? So I have prepared here a graphing paper. an improvised graphing paper because the lockdown prevents us from going out. Okay? Now, like I told you guys a while ago, our non-negativity constraints are now the axes. Like I told you before, okay, these variables can be represented by x or y, which are the more common variables to be used. But for simplicity, we can use t and c. Okay? But in constructing the Cartesian plane, that would mean that our axis would be named, okay, the t-axis and the c-axis, okay, instead of the usual x and y axis. Okay? And so now we construct our Cartesian plane. So, as you know, in your high school mathematics, there are two axes, the x-axis and the y-axis. The y-axis is the one that is vertical, and the x-axis is the one that is horizontal. But in this case, since we did not use x and y axis, and like I said a while ago, we will be using the t-axis and the c-axis. Okay? So this would be our t-axis and this would be our c-axis. And therefore, all coordinates will be in the form t, c. Because the usual format of our coordinates is x, y. The x coordinate is the one that goes first, followed by the y coordinate. What is important is that we are able to plot, okay, these constraint lines into our Cartesian plane. Take note, by the way, that our Cartesian plane, okay, contains 4 quadrants. Okay, this is the first quadrant wherein all values, whether x or y, are positive. This is the second quadrant wherein x's are negative and y's are positive. This is quadrant 3 wherein both x's and y's are negative, and this is quadrant 4 wherein x's are positive and y's are negative. Okay, but why is the Cartesian plane drawn like this? Because we will be using the first quadrant only. Why? Because of the non-negativity constraints. Okay, and since there is a non-negativity constraint, neither of these variables are negative. Okay, so they must be 0 or positive. Thus, we will be using these lines and the first quadrant. Okay, now we first plot these constraints, but take note, guys, that we need to be plotting lines, and lines are denoted by equations, not inequalities. That is why these constraints must be converted into an equality. How? Simply change the sign. Okay, the inequality symbol, just change it to an equality symbol, the equal sign. Okay, so our first constraint, 50t plus 20c is equal to 3,300. We have just changed the symbol, the inequality symbol, into an equality symbol. Okay, so we just need 2 points. Okay, because as we know in our high school mathematics that 2 points, from 2 points we can draw a line. Okay, so how are we going to find those 2 points? We just set either of these variables as 0. Okay, so first one, we set t is equal to 0. If t is equal to 0, then 50 times 0 plus 20c is equal to 3,300. This is 0. Okay, and then c would now be equal to 3,300 over 20, or 3,300 divided by 20, that would be 165. C is equal to 165. And following this format, okay, T is 0 and C is 165, and therefore we have the point 0, 165. Okay? What if C is 0? Then that would be 50T plus 20 times 0 is equal to 3,300. This is cancelled because this is now equal to 0. Now, 50T is equal to 3,300. T is equal to 3,300 divided by 50, and now T is equal to 3,300 divided by 50. Okay, that's 66. T is equal to 66 and C is equal to 0. Therefore, we have the point 66, 0 following this format. Okay? So, we now have 2 points. We can now draw the line. So, where is 0, 165? Okay? It must be somewhere here. Okay? We now count. Assume that 1 square is 10. So, this is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, 160, 170. So, it must be somewhere here. Between 160 and 170. Okay? So, for the other point, 1, 2, 3, 4, 5, 6. This is 60. This is 70. So, 66 must be somewhere here. Towards, it's nearer to 70 than 60. Okay? So, now, what we're going to do is to connect the dots. Okay? And we now have our constraint line. Okay? This would now be our line 50T plus 20C is equal to 3,300. Okay? And this is the point 0, 165. This is the point 66, 0. Okay? And we now have one last constraint to plot. By the way, guys, okay, the non-negativity constraints, like I said a while ago, these are now our axes. Okay, this one and this one. So we have already plotted our non-negativity constraints, 1, 2, and of course, the first constraint. Okay, so that leaves us with just this. Okay, after we have plotted this, then we're done with our graph. Oh, and by the way, this is the graph of the equation 50T plus 20C is equal to 3,300, but not the inequality. Okay, so how are we going to show the inequality in the graph? Okay, if it is a less than or equal to inequality, it has, or we have to shade whatever is to the left or below of the line. If it is greater than or equal to, we are to shade the region that is to the right or above the line. Okay, and since this is a less than or equal to inequality, then we shade this region. Okay, so let's use a different color. Okay. Okay. So all these points here, okay, it actually extends here and there. Okay, these are the points that satisfy the inequality. Okay, one example is this point of origin. Okay, if both T and C are 0, okay, we substitute 0. Okay, that would be 0. Is 0 less than or equal to 3,300? Yes, it is less than 3,300. So this point here, the point of origin, actually satisfies the inequality because it is found to the left. Okay? It is found at the left, okay, of the line or of this line. Okay? So that's just checking. Okay? We are just checking, okay, whether this one of these points really satisfy, or we are just checking whether we have selected the right region. Okay? For the last constraint, okay, we have 3t plus 4c is equal to 380. Okay, we are transforming this, okay, inequality symbol into an equation, okay, just for the purpose of plotting the line. Okay, and then we're going back to this inequality, and then we select what region satisfies this inequality. Okay, so just the same, if t is equal to 0, then 3 times 0 plus 4c is equal to 380. C would now be equal to 380, okay, divided by 4. That's 95. Okay. Now, if C is 0, then that would be 3t plus 4 times 0 is equal to 380. 3t is equal to 380. T is equal to 380 divided by 3, 126.67. Okay? So, we have here the point 0, 95 and 126.67, 0. Okay? We locate this point. 10, 20, 30, 40, 50, 60, 70, 80, 90. So, 95 must be here. Okay, in between 90 and 100. Okay, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. So, 126 must be here. 126.67. And now we're ready to connect these two points. Okay. Okay. So this is now the line 3t plus 4c is equal to 380. Okay. Now going back to the constraint, we have here a less than or equal to inequality, and therefore we are going to shade whatever is to the left or below, okay, of this line. So let's use a different color, green. Okay, so it's this region here. Okay. For the non-negativity constraints, this is a greater than or equal to symbol. Therefore, whatever is to the right, okay, or above, okay, and this one is a greater than or equal to symbol again, and therefore whatever is to the right or above. Okay, so like I said, quadrant number 1. Okay, so what is the region that satisfies all of the constraints? Okay, it's this region here. Okay, this region here. This region here satisfies all the constraints because it is in quadrant 1, therefore satisfying both non-negativity constraints, and they are to the left of this second constraint and also to the left of this first constraint. So it is this region, okay, that satisfies all of the constraints. Okay, in finding for the feasible region, we are looking for the region that satisfies all, not Not just one, not just two or three constraints, but all. In this case, 4 constraints. Okay? So, again, this is what we call now the feasible region. Okay? And the feasible region is bounded by these points. By the way, this is from the second line. This is 0, 95, and this is 126.670, but this point is outside of the feasible region. So, what bounds this feasible region? This point, 0, 95, the point of origin, this point, 66.0, and this point, which at this point we don't know yet. Okay, but we can see that this point is the intersection of this line, the first constraint, and this line, the second constraint. So we just solve for the solution between these inequalities, or in this case, these two equations. Okay, so we just solve them. We create a system of equations, okay, and then we solve for the solution. The solution of this system of equation would now be the intersection between these two lines. Okay, so 50t plus 20c is equal to 3,300. Okay, and then 3t plus 4c is equal to 380. We multiply this equation by 5 so that this term here would be equal to this, so that it would be easier to eliminate. Okay, so 50t plus 20c is equal to 3,300, and then we have 5 times 3, 15t plus 20c is equal to 5 times 380. That would be 1,900. 1,900. So we just subtract the second equation from the first equation. 50t minus 15t, that would be 35t. 20c minus 20c would be 0. 3,300 minus 1,900 would be 1,400. And t would be, okay, 1,400 divided by 35. 40. Okay, so we have, okay, t is equal to 40. We substitute it to the second equation because this is a smaller equation. I mean, the terms, okay, the numerical coefficients are smaller. Okay, so 3t, okay, 3 times 40 plus 4c is equal to 380. Okay, 3 times 40 is 120. We transpose that to the other side. Okay, this now becomes negative. So 380 minus 120, that would be 260. 4c is equal to 260. Okay, and therefore c would now be equal to 260 divided by 4. That's 65. If t is 40 and c is 65, then we have the point 40, 65. Therefore, this point here is 40, 65. Okay? Is it 10, 20, 30, 40, 50, 10, 20, 30, 40, 50, 60? Wait. No, 10, 20, 30, 40. Yeah, 40. Okay, and then 10, 20, 30, 40, 50, 60. Okay, it's between 60 and 70. Okay, so yeah, it is 40, 65. Okay, so we have now our corner points 0, 95, 0, 0, 66, 0, and 40, 65. More often than not, guys, okay, our optimal solution would come from these points. These points are what we call the extreme points, okay, or the corner points, because these are the corners of our feasible region. Okay, the graphical method would actually require us to plot, okay, our objective function and then move it slightly away from the point of origin. And then the last point that it will touch before leaving the feasible region would be the optimal solution. Okay? But there is an easier way, and that would be to test all of the corner points. Okay? Of course, we can eliminate 0, 0 because that would mean you are not selling anything. How are you going to get a profit if you're not selling anything? Okay? That leaves us with 3 points. Okay? So, 0, 95, meaning we are not going to sell any table, but we are going to sell 95 chairs. 66, 0, meaning we are going to sell 66 tables, but we are not going to sell any chair. And this point here, wherein we are going to sell 40 tables and 65 chairs. Now, we test all of these. Okay? Now, first, okay, we get the objective function, maximize the profit, which is equal to 200t plus 100c. Okay, first one. Okay, let's try 0.95. Okay, so 200 times 0 plus 100 times 95. Okay, profit would be equal to 100 times 95. That's 9,500. Okay, second would be this point here. Okay, 66.0, meaning we are going to sell 66 okay, tables, which will yield us a profit of 200 per table. Plus, we are not going to produce any chairs. Okay, so 100 times 0. Okay, 200 times 66 is 13,200 plus 0, then that would be our profit. Okay, so between these two, we are going to maximize profit here. I mean comparing it to the first one. Okay, but we still have one point that we have not yet tested. Okay, and let's see. Okay, so 200 times 40 plus 100 times 65, because we are going to produce 40 tables and 65 chairs. Okay, 200 times 40 is 8,000. Okay, and 100 times 65 is 6,500 plus 8,000, that would be 14,500 of profit. Okay, so among the three, this combination of tables and chairs will yield the most profit. Therefore, our optimal solution is, okay, 40 tables and 65 chairs. Okay, so we have arrived at this answer using the graphical method, and now we proceed to solving this same problem using the simplex method. Okay, so in the simplex method, it's just the approach that changes. The steps in solving the problem would be different, but we will be using the same representations and the same objective function and the same constraints. Okay, so how are we going to solve a problem using the simplex? At this point, I'm going to tell you that solving maximization problems and minimization problems are so much different under the simplex method. Okay, but let's not worry about the minimization problem first. Actually, that's more tedious than the maximization problem. Well, actually, in solving a minimization problem using the simplex method, we are converting the minimization problem into a maximization problem and then solve it as if it is a maximization problem. And therefore, this is crucial. Why? Because we need to master how to solve problems using the simplex method for maximization problems, because like I said, in solving minimization problems, we just transform it into a maximization problem, and then after that we solve it as if it is a maximization problem. So we need to really master this approach. Okay, so we are going to rename this objective function such that all terms including the profit variable will be on one side, and then on the other side there would be 0. Okay, so how are we going to do that? We just transpose this. Okay, so our objective function now becomes negative 200t minus 100c plus p is equal to 0. Okay, take note, we have just transposed this. Of course, if it goes to the other side of the equation, the sign changes. So that's why it's negative here. Okay, and then after that, okay, we introduce slack variables. We are going to convert these constraints, these inequalities, into equations. Okay, and in doing so, we are going to introduce slack variables. Okay, what are slack variables? Slack variables are variables that are added to, okay, to convert the constraint into an equality. Okay, it is to be interpreted as the amount of unused resource. Okay, so take for example this inequality. How are we going to transform it into an equality? Okay, it will become 50t, okay, plus 20c plus S1. We are going to name the first slack variable as S1. That would be equal to 3,300. Okay, think of it as an unused resource. Okay, so if for example we are going to produce 2 tables and 2 chairs, how much wood are we going to use? Okay, so 100 plus 40, that would be 140. Okay, since we have only used up 140 board feet of lumber and we have 3,300 available, ibig sabihin, okay, we have not used 3,160. Okay, 3,300 available resource, which is wood, okay, minus 140 that we used, there is still 3,160 unused. That would be represented by our slack variable. Okay, but if we are able to use up all 3,300, then we have no slack variable. Okay, because there is no unused resource. This would now be equal to 0. But in order for us to be able to convert this inequality to equality, okay, we need to introduce this slack variable. Okay, now the second constraint, okay, would be 3t plus 4c plus the second slack variable. Okay, it's important to have a different slack variable because this one represents unused wood This one represents unused labor hours. Okay? So, 380. Okay? So, going back to this, no? Okay? If we have used 140 and we have 3,160 unused, would that be equal to 3,300? Yes, all the time. Okay? So, whatever number of tables or chairs we're going to produce, okay, it will always be equal to 3,300 because this variable picks up the slack. Okay? Now, okay, the same is true here. Okay? If we are going to produce 2 tables and 1 chair, we will have used only 10 labor hours. Okay? So, we still have 370 unused. Okay? Which is now represented by this slack variable. Okay? These two are different because this one represents unused wood. This one represents unused labor. Okay? So, after that, okay, we are now going to create our Simplex Tableau. Okay? So, we have here our variables T, C, S1, S2, and P. And then, of course, the numbers that are not represented by any variable will stay on this side. Okay? And then, of course, our slack variables go here. And our profit. Okay? And since our profit is here, okay, our objective function goes here. Okay? So, in drawing our Simplex Tableau, okay, our constraints, okay, will stay here, and our objective function stays at the bottom. Okay? So, we just copy, okay, the numerical coefficients. Okay? So, starting with the first constraint, this is 50, this is 20, this is 1. We have no S2 here in this constraint, so 0. We also have no P, 0, and 3,300. Like I said, numbers that are not represented by any variable will be here, will be placed here. Okay? The second constraint, 3, 4, we have no S1, we have an S2, which is 1, 0, and then 380. And then finally, our objective function, negative 200, negative 100, no S1, no S2, we have AP here, and 0. So this is now our Simplex Tableau. Okay. Next thing that we have to do would be to search for the number here at the bottom. Okay. By the way, we have created a row of numbers and columns of numbers. Okay. So this would be row 1. Okay. Row 1, row 2, row 3. Okay. And then our different variables. Okay. And these numbers here, these are our columns. Okay, so this is row 1, row 2, row 3. Now we look at row 3. Okay, we look for the most negative number. Okay, so when I say most negative, this is the furthest, okay, to the point of origin. Okay, so in the number line or in the Cartesian plane, okay, we have the point of origin at the center. Okay, all numbers to the left are negative numbers. All numbers to the right are positive numbers. We only look at numbers to the left, meaning negative numbers. Which one is the furthest from the point of origin? The most negative number. That's what we're looking for. So, in this case, the most negative number is 200. Okay? And now, this entire row, okay, this entire row here, okay, becomes now what we call our pivot column. Okay. Okay. That is now what we call our pivot column. Okay. And what do we do with this pivot column? Okay. We are going to divide, okay, these numbers here by the corresponding number in the pivot column. Okay. So 3,300 divided by 50. Sorry. 3,300 divided by 50, that would be 66. Okay, we place here 66. Okay, and then 380 divided by 3, 380 divided by 3, that is 126.67. Okay, after that we are going to choose whichever is lower between these resulting numbers. Between 126.67 and 66, the lower number is 66. And therefore, okay, the number that corresponds to this smaller number in the pivot column, okay, is what we call now the pivot element. Okay? And what do we do with this pivot element? Okay? Our goal here is to transform this pivot element into 1. And then all other numbers in the pivot column must be 0. We must transform these numbers into 0, and then this one, or I mean, we must first convert this number, this pivot element, into 1, and then all numbers above or below this pivot element must be transformed into 0. How are we going to do that? By means of what we call the row operations. Okay? How are we going to transform this pivot element into 1? Okay? So, by the way, row operations meaning we have to perform these operations on the entire row. Okay? So, if we are going to multiply a certain number to this number here, we also multiply the same number to the rest of the row. Okay? That's why we call it row operations, because it is applied to all numbers in the row. Now, how are we going to transform this into 1? Okay? We are going to multiply 1 over 50 to row 1. Okay? And now, that becomes our new row 1. Or, you could also simply divide row 1 over 50. You divide row 1 by 50. Okay? Row 1 over 50 would be our new row 1. Okay? So, we draw up another Simplex Tableau. Okay? Okay. And then we now perform our first row operation. So, we are going to divide all numbers here by 50. So, 50 divided by 50 would be 1. Okay. 20 divided by 50 would be 0.4. I think it's better to use fractions. Okay. Take note, it is better to use fractions, okay, than decimals, because fractions are more exact than decimals. Okay. And then 1 divided by 50, then that would be 1 over 50. Okay. 0 over 50, 0. 0 over 50, 0. 3,300 divided by 50 would be 66. Okay. So that's our first row operation. Okay. After that, okay, our goal is not yet complete, because like I said, okay, we are to transform this pivot element into 1, and then all other numbers above or below it must be 0. So 3 here must be 0, and 200 here must be 0. So we need 2 more row operations. Okay? Now, how are we going to transform this number into 0? Okay, using our new row 1. Okay? Our second row operations would be negative 3 times the new row 1, okay, plus row 2 would be our new row 2, okay. And finally, our last row operations would be 200 row 1, 200 times this new row 1 plus row 3 is our new row 3. Okay? So let's perform. By the way, we are done with this row operation here. Now, let's perform this row operation. So, negative 3 times this new row 1 plus row 2. Now, negative 3 times 1 is negative 3. Plus 3 is 0. Okay? Negative 3 times 2 over 5. Okay? That would be negative 6 over 5. Okay? Plus 4. Okay? That would be 14 over 5. Okay? Yes, 14 over 5. Okay? Negative 3 times 2 over 5, that would be negative 6 over 5. Okay? To illustrate, okay, let's have side computations here. Okay? I think it would be better for us to understand, okay, if I would be performing side computations here. Okay, now, negative 3, okay, times 2 over 5. Okay? That would be equal to 6, negative 6 over 5. Okay? Plus 4. We can rename 4 into 20 over 5. Okay, 20 over 5 is the same as 4. Okay? So, we add negative 6 over 5 plus 20 over 5. That would now be 14 over 5. Okay? So, this is 14 over 5. Next, negative 3 times 0 would be 0. Okay? Plus 1 over 50. Okay, 1 over 50. Negative 3, okay, times 1 is negative 3. Okay? Oh, no, sorry. Negative 3. Oh, times. Okay, I think this is wrong. Okay. Negative 3 times 1 over 50. Okay? Negative 3 times 1 over 50, that would be negative 3 over 50, okay, plus row 2, okay, plus 0. So that would be, this should be negative 3 over 50. Okay, sorry about that. Okay, this should be negative 3 over 50. Okay? Next, negative 3 times 0 would be 0 plus 1 would be 1. Okay? Negative 3 times 0 plus 0, 0. Negative 3 times 66. Okay? Negative 3 times 66 is negative 198. Okay? Negative 198. Okay? Plus 380. Okay? Plus 380. That would be 182. Okay? So we're done with our second row operations. Now, our last row operations. Okay. 200 times 1, okay, that would be 200, plus negative 200, that would be 0. 200 times 2 over 5, okay, that would be 400 over 5. 400 over 5 is 80. Okay, 80 plus negative 100, that would be negative 20. Okay, 200 times 1 over 50, that would be 4 plus 0 is 4. Okay, 200 times 0 is 0, plus 0 is 0. Okay, 200 times 0 is equal to 0, plus 1 is equal to 1. And finally, 200 times 66. 200 times 66 is 13,200, plus 0 is 13,200. Okay, we're done with this third row operations. Okay, and now we have a resulting tableau. By the way, once we perform these row operations, okay, you notice we have here slack variables. Okay, so look at the pivot element. Okay, it is where S1 and P would meet. Okay, now after we have performed these row operations, whatever element is above, or whatever variable, okay, is above, okay, above this, or whatever is the variable that is the heading of this pivot column, okay, would have to exchange with this slack variable here. Okay, so we now have here T and S2 and P. Okay, I hope that was clear. Okay, so again, T here is this pivot element is the intersection between T and S1. Okay, simply just put T, substitute T for S1. Okay, and then we're done with our first set of row operations. Now we will know that we are done solving if there are no longer any negative numbers here in row 3. But as you can see, we still have, okay, a negative number here. Okay, and since there is no other negative number, this automatically becomes now our pivot column. By the way, guys, we are just going to repeat the process, okay, until all the negative numbers would be gone in this third row. Okay, so we just repeat the process. Whatever is the most negative, that would be our pivot column. Okay, and then we divide, okay, this number here by this number here. So 66 divided by 2 over 5. Okay, when dividing fractions, we are just going to multiply it with the reciprocal. So 66 times 5 over 2. 66 times 5 over 2. Okay, so that would be 165. Okay, 182 times 5 over 14. 182 times 5, okay, over 14. That would be 65. Okay, between 65 and 165, which is smaller? Of course, it's 65. And therefore, okay, the number in the pivot column that corresponds with this number here, the smaller number here, would be now our pivot element. Okay? So this is our pivot element. Okay? Okay, pivot element. This entire column here is what we call the pivot column. Okay? And now we perform a new set of row operations. Okay? Because our goal is to transform this pivot element into 1, and then after that, all elements above, all numbers above or below this pivot element must be transformed to 0, just like what we did in this first set of row operations. And we will be needing a new sheet of paper. Okay, now we are going to draw up another tableau. Okay, so T, C, S1, S2, P. Okay, our variables. Okay. Okay. So our first row operations would be, okay, we multiply 5 over 14 row 1, okay, would be now our new row 1. Okay? No, sorry, row 2. Okay, row 2. This is the second row. 5 over 14 multiplied to all numbers here in the second row would be our new second row. Okay? So, 5 over 14 times 0 is 0. Okay? 5 over 14 times 14 over 5 would be 1. Okay? 5 over 14, okay? 5 over 14 times this number here, negative 3 over 50. Okay? So, 5 times negative 3, that would be negative 15 over 700. Okay? 14 times 50 is, yeah, 700. Okay. In lowest terms, divide. Okay, to get the lowest terms, we just divide by 5. Okay, that would be 3 over 140. Is it? Okay, so negative 15 divided by 5 is negative 3. 700 divided by 5 is, yeah, 140. So, okay, we are going to place here negative 3 over 140. Okay? Negative 3 over 140. And the next, where are our row operations? Here. Okay, 5 over 14 times 1 is 5 over 14. Okay? 5 over 14 times 0 is 0. 5 over 14 times 182, okay, is 65. Okay? 5 times 182, okay, divided by 14. Okay, 65. Okay, we're now done with our first row operations. Okay? Next would be to transform these numbers to 0. Okay? And how are we going to do that? Okay? Negative 2 over 5 times R2 plus R1 would be our new R1. Okay? And finally, 20 R2 plus row 3, okay, would be our new row 3. Okay? And so let us now perform our second row operation. Okay, so negative 2 over 5 R2. Okay, this is your new R2. So negative 2 over 5 times 0 is 0 plus row 1, okay, plus 1 is 1. Okay, negative 2 over 5 times 1 is negative 2 over 5 plus 2 over 5 is 0. Negative 2 over 5 times negative 3 over 140. Okay, so let's do some side calculations. Negative 2 over 5 times negative 3 over 140. That would be 6 over 700. Okay, so let's just verify. 5 times 140 is 700. Okay, so 6 over 700, okay, in lowest terms is 3 over 350. Okay, so negative 2 over 5 times negative 3 over 140 is 3 over 350. Okay, plus 1 over 50. But 1 over 50 can also be expressed as 7 over 350. Okay, 7 over 350 is just the same as 1 over 50. Okay, okay, so 3 over 350 plus 7 over 350, that's 10 over 350, or in lowest terms 1 over 35. Okay, so let's place 1 over 35 here. Okay, next, negative 2 over 5 times 5 over 14. Okay, we will cancel the denominator and the numerator. Okay, that leaves us with negative 2 over 14, or negative 1 over 7, plus 0. So that's negative 1 over 7. Okay, and then negative 2 over 5 times 0 is 0, plus 0 would be 0. Okay, and then negative 2 over 5 times 65. Okay, so 2 over 5, okay, negative times 65, that would be negative 26, plus 66, that would be 40. Okay, so we're done with our second row operations, and to our last row operation, let's now perform our last row operations. Okay, 20 times 0 is 0, plus 0 would be 0. 20 times 1 is 20, plus negative 20 is 0. 20 times negative 3 over 140, that would be, we will cancel 20. Okay, and then we will be left with 7 here. Okay, so that's negative 3 over 7, plus 4. Okay, 4 is 28 over 7. So plus negative 3 over 7, that would be 25 over 7. Okay, and then 20 times 5 over 14. Okay, 20 times 5 over 14, that would be the same as 100 over 14, or 50 over 7, plus 0 would be 50 over 7. 20 times 0 is 0, plus 1 would be 1. Okay, and then 20 times 65 is 1,300, plus 13,200, that would be 14,500. Okay, by the way, our pivot element is this number, okay, which is the intersection between S2 and C. So we are going to change this slack variable here into C. So this would be T, This would be C, and this would be P. Okay? So, let us check. Are there any negative numbers in the third row? None. Okay, we have eliminated all of the negative numbers here in the third row. Therefore, we're done. Okay, we end here. Now, it's time for us to interpret the results of this simplex method. Okay? So, okay, our T is equal to 40. Our C is equal to 65. And when we are going to use these values of T and C, we are going to arrive at a P amounting to 14,500. Let us go back to our answers using the graphical method. Okay? Okay. Our answer a while ago using the graphical method is 40 tables. Okay? And let us now compare it with our answer using the simplex method. Okay? So 40 tables, okay, the same, 65 chairs, and a profit of 14,500.